Hello, this is Lazarus at TelecomTech, where telecom and networking technologies are simply explained. Today, we'll be simply explaining how to configure multi-protocol BGP Ethernet VPN for VXLAN on Cisco Nexus switches. If you like my content so far and you're interested in seeing more networking and telecom technologies simply explained, then please subscribe now to the channel. And when you subscribe, make sure to enable notifications like so that you'll be informed of new content. If you like this video, make sure to click that thumbs up button. In a previous video, we went over the operation of the MP-BGP EVPN solution for VXLAN. And in particular, we examined how this technology can be used to learn MAC addresses of hosts on the same VNI across the VXLAN fabric. Now remember, MP-BGP EVPN is a solution that resolves the scalability issues that come with statically defining the VTEP to VNI mappings, as well as the inefficiencies that the flood and learn operation that the multicast underlay uses as well. Now in this video, we'll be focusing on a configuration on a Cisco Nexus infrastructure, but we'll be looking at layer 2 VNI communication. So we'll be spanning a single VNI across the VXLAN fabric, allowing two hosts on the same layer 2 segment to communicate over that fabric. Now just a note, we'll be touching upon various aspects of BGP configuration, including iBGP peerings, route reflectors, and BGP communities. So if you're a bit rusty on these topics, make sure to look at them in my BGP playlist. So here's our topology. We have two PCs on the same subnet, each connected to a different VTEP that's part of the same VXLAN fabric. The VTEPs are configured such that the PCs are both on VNI 6501. We've already configured the underlay network with OSPF, with multicast PIM sparse mode, which of course, as you remember, is still a prerequisite. And we've configured this spine switch here as the rendezvous point. If you need to review these aspects of the deployment, take a look at my previous videos on my VXLAN playlist. Now the next thing we're going to do is we're going to take a look at the spine switch configuration, and specifically we're going to look at the BGP configuration. This is where all of the MP-BGP magic takes place. We start off by entering the BGP configuration mode and specifying the BGP AS number, which in our case is 100. Then we specify the BGP neighbor that we are configuring. In this case, our neighbor is VTEP1. Now remember, this is an iBGP topology, and for iBGP, you don't need to have your neighbors directly connected. On the contrary, all the BGP peers in here must have a full mesh BGP peering. Now under the neighbor configuration, we configure the remote AS, which is also 100, and that's what makes it iBGP. And we configure the spine to use the loopback 0 interface as the source of the BGP messages. Now this next command is where MP-BGP EVPN comes in. Here we configure for this neighbor the address family of L2VPN EVPN. This means that the addresses that BGP will be advertising belong to the layer 2 Ethernet VPN family. In other words, BGP will be advertising MAC addresses. So this command enters the address family configuration mode for EVPN. And here we must configure the following. We have to first enable BGP communities, including extended communities. Now, extended communities must be enabled because it is these extended communities that contain VXLAN specific information, such as VNIs. And finally, we must configure this BGP peering with 1.1.1.1 as a route reflector peering. This command here tells the spine switch that this neighbor is a route reflector client. So that's the configuration for the peering with VTEP1. Now let's configure the peering for VTEP2 as well. This is virtually identical with the peering for VTEP1. We have the same AS number, we have the same address family commands, and the same community and route reflector commands. The only difference is that the peering is made with neighbor 2.2.2.2, which indeed is VTEP2. Now let's go over to the VTEPs and configure their end of the BGP peerings. The configuration is the same on both VTEPs 1 and 2. and it's similar to what we saw in the spine switch. We enter the BGP configuration mode and specify AS100. We configure the 3.3.3.3 spine switch as the neighbor, and we specify the same ASN of 100. We configure the loopback 0 interface as the source of our BGP updates, and then we configure the address family of L2 VPN EVPN to ensure that MAC addresses will be advertised using BGP. Once again, we enable our BGP extended communities. Now note here that there's no specific configuration to make this BGP peer a root reflector client. This was taken care of at the spine, which is the root reflector itself. Now the last thing we must configure are the commands on the VTEPs that enable the VXLAN operation. Specifically, we must configure the VNI and the NVE interfaces. To do this, we start by configuring the VLAN on which the PCs are connected. In our case, these ports are configured on VLAN 10. So we go into the VLAN configuration mode in our VTEPs and associate that VLAN with VNI 6501. Next, we have to configure the NVE interfaces. Remember, this is the Network Virtual Interface, or the NVE. Now, this is the same as what we have configured in the past, but I'd like to bring your attention to this particular command here, which is the Host Reachability Protocol BGP. Now, this is the command that tells the VTEP to use BGP as the protocol with which it will learn MAC addresses. It's the connection, essentially, between the VXLAN configuration here and the underlying MP-BGP EVPN operation. The member command here tells the VTEP that this interface will tunnel traffic for VNI 6501, and the multicast group address that corresponds to this VNI that we're using is 239.1.1.1. Now remember that even though we're deploying MP-BGP EVPN, the multicast underlay is still needed to take care of other types of multicast traffic. Now our configuration is essentially complete. Now I'd like to show you what the BGP table within VTEP1 looks like. So with this command here, the show BGP L2 VPN EVPN neighbors command, we can take a look at what MAC address information VTEP1 sends out to our root reflector. Here we see the entry in the BGP table, and we can see the MAC address of PC1. Now this entry comes with some more information here, including a root distinguisher, which makes this a unique route on the topology, as well as the next hop IP that's being advertised, which of course is VTEP1 itself. We can also see the layer 2 VNI that's being advertised, which is the 6501 VNI. Now all of this extra information is contained within those BGP extended communities, and that's why we need that feature enabled. Now we won't go into detail concerning the rest of the information here, but suffice it to say at this point, MP-BGP is being used to advertise the MAC address of our local PC1 to the VXLAN topology. So anywhere where there is a VTEP with the same VNI, this information will be proliferated throughout the VXLAN topology. For now, I hope this video has been useful, and if you liked it, please click that thumbs up button. If you'd like me to address other related topics, feel free to let me know in the comments below. And please subscribe to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this video has been helpful for you, and I'd like to thank you for watching.